Hello students, this is Dr. Faizan Mirza. In this video, I'll be covering a question in which they ask you to calculate the t value using the formula provided and the data that was given to you. And using that t value, you were asked to then compare it with the critical value and find out whether the difference in the mean of the two sets of data of the paired set of data, was it significant or was it due to chance? So this question is actually related to plans. This question came back in October November 2010. This was the second variant of paper 5. Now in this question, it's a fairly simplistic question to begin with. Even it's a very simple question. Again, I would recommend that once you are done with this video, do attend this question all by yourself to see how much you were able to comprehend. A student noticed that the leaves on the plant growing close to the wall had two sorts of leaves. The leaves next to the wall were in shade and looked different from the leaves on the side away from the wall that were exposed to the sun. The length of the internodes of on the stem also looked different. So there are two type of leaves. One which actually are in shade because they are next to the wall, and the others which are exposed directly to the sun. The student decided to investigate the difference by measuring some features of 30 leaves and internodes from each side of the plant. So this is the shape of the leaf. This is what the internode means. You don't need to keep in mind what internode means. Although it's something simple, you probably must have studied this in your lower classes. If not so, the diagram is provided to you for your assistance what an internode is. So whenever a new term comes, the hint is already there in the question or somewhere in the figure. You just need to find that hint. So what is internode? Internode, you can see, is the distance between two adjacent leaf stalks. How many leaves were being taken? 30 leaves of from each side of the plant. It means that the student is taking 30 leaves from shade and 30 leaves from sun. So this is the small n value for each. Now, eventually, if you'll be calculating the degree of freedom for this, the degree of freedom would then be degrees of freedom would be what? Would be n minus 1 plus n minus 1. And here the n would be 30 minus 1 plus 30 minus 1. And the answer would come out to be 58. So this is how the degree of freedom is calculated. So you just need to read very carefully how many single observations were taken for each set of data. How many observations were taken for each set of data, not the single observations. So n for each. Anyhow, let's move on. Table 1.1 show the results of the students. Now the students table 1.1 results mean the student is using the mean internode length. Mean means it's continuous data. Mean because it's 30, the student is taking 30 of each. Mean internal length in millimeter, mean surface area in millimeter squared, mean mass of leaves in milligrams, mean leaf surface area to leaf mass ratio, rate of water loss milligram per millimeter squared per hour. Shaded leaves and exposed leaves, you can see the values 23 plus minus 4 means that this is the length, or you can say the length, mean length divided together with the standard deviation. Mean plus minus this, because this is the value provided, so this must be standard deviation, because that's how we mention standard deviation together with mean. So 23 plus minus 4, 15 plus minus 3, this is the standard deviation provided to you. So all the standard deviations are provided to you for each set of mean that's given. State the independent variable being investigated. Now, independent variable we know is the cause. So what's the cause here? The cause is light intensity, because the exposed leaf will have different light intensity and the shade leaf will have a different light intensity. So this will be our independent variable. The next, they are saying outline the procedure the student could use to obtain these results. These results mean that you are asked outline. You won't use VPSR. You don't really need to describe the whole procedure for each, because they are being they actually are asking outline the procedures that the student could use to obtain these results. So you need to explain and give a procedure how the mean internode length was calculated, how the mean surface area was calculated, how the mean mass was taken, how this ratio was calculated, and how the water loss was done. So how all of these need to be done? So what we can do, we can again go through the same thing. What we'll do, you will collect the leaves from the same height of the plant. Also prefer to collect it from the same side. So equal sunlight excess can be correlated. Surface area of all 30 leaves from each side will be calculated. Mean surface area will be taken as well. How is the surface area calculated? This is done by placing the leaf on a millimeter grid. and counting the number of squares that the leaf occupy on the edges. More than half in squares are counted as whole, less than half covered are ignored. So this is how the surface area is calculated. You just keep it on a grid, you draw an outline, and you just count the number of squares which it occupy. And on the edges, all the squares that are that are actually more than half in, they are counted as a whole square. And any square which is less than half in, you ignore it altogether. Add up all these squares together, that give you the surface area. Okay, so that's done. Then surface is calculated. How will you move to the next thing? So calculating the surface area. Moving on, you need to just find out how the internode distance can be measured. Now the internode distance in the diagram is shown. It's not linear. It's not straight line. So you can use a string. You can use a string to measure the internode length and measure the string on the scale or a ruler, and again find the mean for the 30 leaves. Now how will you measure the rate of water loss? You can use the photometer there. With intact shoot, rate of water loss in rate transpiration is calculated by noting the time taken for air bubble to move unknown distance in the photometer scale. Rate, it will be 1 upon time. We know we need to calculate rate is always 1 upon time. So mass of 30 leaves could be noted using electronic balance. Ratio of leaf mass and rate of water loss can be calculated as well. Calculate the standard deviation for each variable. Record in the table as mean plus minus standard deviation. Wear gloves for protection against irritants and plant surface. Use it on the plant surface. We are using electrical appliance, so dry hands and avoid electrical shock. So this pretty much covers up all the content that was there in the table that the student could have used. Moving on, the student carried out t-test for the leaf surface area to leaf mass ratio for the internode length. The leaf surface area to leaf mass ratio gave the results of T 12.6. So 12.6 is already given to you as a value of the internode length. The formula for the t-test is provided as T is equals to, this is the formula of t-test. How you use this formula to calculate the value of T? X1, 1, 1. All these values which have 1 pointed, it means they all refer to the first set of data. So x bar 1 means the mean of the first group of data. S1 squared means the standard deviation of the first set of data. Small n1 means the number of observations the first group of data. Similarly, everything which is mentioned as twos, the mean, the standard deviation squared, and the number of observation, they all refer to the second group of data. So we just apply the rule of Bodmer's here. We just plot the values and we calculate the answer. So complete the calculation to find out the value of T for the internode length. Show your working. Now you have to show your working for the internode length. We need to place the numerators here. The numerators are x bar 1, x bar 2. So if we go back, our values of x bar 1, x bar 2 are provided as 23 and 15 each. The values for standard deviations are given as 4 and 3. We know there are 30 of each type. We'll use this and we'll apply this here. So 23 is the mean of one, 15 is the mean of the other. 4 already is provided to you as a standard deviation of first set of the data. 3 is the standard deviation of the next set of data. Squared, divide by 30, and you just subtract it here. You add 8 here. You just place 8 in the numerator. You don't have to calculate this entire thing. They have not asked you. Only the missing parts of the calculation have to be completed. So 8 divided by 0.9, the answer comes out to be 8.9. So in this case, your t is value, the value of t is 8.9. Table 1.2 shows the critical value at p less than 0.05 for this test. Degree of freedom, I have already shown to you that we'll be calculating at 58. Now, since 58 is not provided to you, you are given 40 or 60, so we'll prefer 60. 60, at 60, the critical value is provided as 2.0. Again, the same thing here. Our calculated value of t is 8.9 and the critical value is 2.0. So once again, in this case, the t value is greater than the critical value. It means the results are significant and it's not due to chance, but due to some other factor. So the difference in the mean is because of some other factor. In this case, the some other factor is the light intensity. In further investigation, the student cut sections of leaves from the shaded side and the exposed leaf of the plant. The following procedure was carried out. Transfer sections were made of each leaf. A high power drawing was made from these sections. The relative thickness of both leaf and cuticle were measured using an eyepiece grating, and difference in the distribution of chloroplast was observed. Leaf from the shaded side of the plant, leaf from the exposed side of the plant. You can see the width is very different. You can see the chloroplast distribution is very different. You can see the packing of the cells is very different. You can see the number of the amount of air space is different as well. The thickness of the cuticle is different. So a lot of differences can be seen. Explain how the true thickness of the leaf could be measured. Again, simply using the light microscope with an eyepiece graticle that had already been calibrated using a straight micrometer. With reference to the student results, state what conclusion can be drawn about the differences in the adaptations shown by the shaded leaves and exposed leaves of the plant. So just look at the diagram here and start to mention. So the shade leaves have a thin cuticle, leaf is thin, cell density is less as well as compared to the exposed leaf. Large space is visible. This allows better gas exchange. The leaf is having a large surface area to absorb light than exposed leaf. So this is how it is. These conclusion can be gauged from these diagrams, and you have to state how these adaptations actually help the shade leaf and exposed leaves of the plants. So this question was of 20 marks. It was a long question, but it covered a pretty much something very interesting, which is the t-test and how the calculation of the t-test is to be performed and how it needs to be compared with a critical value. So that's it from my side. I hope that was helpful for you. Thank you so much.